Hello everyone, today we're looking at another lead code problem. This is 2402 meeting room number 3, which is a hard problem. So in this problem we are given n rooms and we are given m meetings, let's say, which is nothing but 2D array of the meeting start and end time. Now, if we can think about how our meetings are scheduled, let's say a meeting goes from 3 to 5, which means it runs for 2 hours, but at 5, the meeting room is free. So the end is excluded. And what we have also told is that the start times are unique, so there is no duplicate, so there is no overlapping meetings that we'll have to worry about. Then they've also given us few conditions. Let's run them in the reverse order. So the first thing is that if there are two meetings looking for a room, then the meeting with the lowest start time must get allocated the room, which gives me the signal that my meetings needs to be sorted by start time. Okay. Next, if no room is available, then the meeting gets delayed till it is available. Okay, we'll handle this condition. And the first one, if the meeting takes place, each meeting takes place in a room with the lowest number, which means if there are a bunch of meeting rooms available, then we have to pick the one with the lowest number. Given all of these conditions, finally we are expected to return the room number that has the most meetings. Okay, so from these inputs, there are a few things that we'll have to a few observations, right? The first thing is that my meetings needs to be sorted if it is not already sorted. Second thing is the room that has the maximum meeting tells me that I need a counter for the number of meetings every room had. Okay, and the third one is that I always want to pick the room with either the lowest ID or the room number. So let's say room number, or if there are meetings that are still running, I will be delayed, but eventually I will pick the room where the meeting ends first. So I need something ending first. Okay, so from here I can conclude that I need min heap because I need the lowest room number and I also need the lowest end time. But these two cases are different. So you will look for lowest room number if you have already rooms where the meetings have concluded. So in that you have to pick the lowest number. And if the meetings are still not concluded, then among all of the meetings that are running, the one that will conclude the first with the lowest n is what I'll be interested in. So these are the key observations. Once we have made the key observations, then the problem becomes quite simple for us. So let's run through the two cases, and then we can quickly jump to the code after that. So let's say I have a min heap, okay, and in the min heap, I'm gonna store my data as end time, comma, room number. Okay, and so what this tells us is at any point of time, okay, so I have bunch of meetings. Okay, meetings are of the range of 1 to 10 power 5. Okay, so I'm looping through these meetings and I come to a meeting which has start comma end. Now I'll check using this end. I'll check is there any or let's say are there, because they can be multiple, are there any rooms with n time lesser than or equal to my current end? If it is, then what I'm going to do is collect all these rooms, find the min room number, and then push it back to the heap, min heap, as n comma min room number. Okay, and what happens to the rest? What happens to the rest that I collected, which are already concluded? So these I can push back to the min heap as already ended. So let's say 0 and the room numbers. Okay, so this will be a for loop here. Now this is yes. What happens if there is a no? No, there are no meetings which have concluded so far. Okay, doesn't matter. Give me the room with the lowest end time, okay, which is equal to the earliest ending meeting, okay, but it also implies that I have to wait. Okay, so how much is the wait period? The wait period is the implies that I will have to wait. Okay, so after the waiting, what is my new end? So my new end will be my current end minus start, but it gets delayed by the end time of the earliest ending meeting. So now I will add to my min heap this n dash, comma, the room number that corresponded to this meeting. So these are the two cases. We can now look at the code for these, and there is not much to the code if you understand this logic. Let's see, def most booked. Alright, so here I get n, which is the number of rooms, okay, and then I get meetings, which is list of int. So remember, this was start, comma, end. Now from all of this, I want to find the room number which had the maximum number of meetings, so that's an integer. So let's return an integer. Alright, so first meetings dot sort, and then let's have our counter, which is equal to 0 or dash in range of n, because I want my meeting rooms here. Alright, so now this is done. Now let's initialize our min heap. Okay, so when all of the rooms are not occupied, when it is just bootstrapping, then all of the n rooms are available for me to pick it up. So which means we will have to initialize the min heap with these rooms, so that as and when I am processing the meetings, I keep pulling these rooms out of the min heap. So let's do that part. So let's say the end time is 0 and the room ID is what I'm going to be filling in. So for room ID in range of n. Now let's process for start comma n in meetings. Okay, so now we look at case 1. In case 1, what happens? Meeting rooms are available. Now, how do I check if meeting rooms are available? I can look at the start of the min heap. So, if min heap of 0, which is the earliest ending meeting, and then 0 of that, which will give me end time, if this is lesser than or equal to start, which means either this meeting has already exhausted or it is going to end at the time when my next meeting is about to start. So this is good enough. Now what we want to do is, there may be more rooms that are available. So what we want to do is, let's say my meeting starts at 5. And let's say there were few meetings attended at 1, 2, 3, 4. And let's say their room numbers were different. Okay, so let's say this was 1, this was 2, this was 3. So if I look at my min heaps output, right, I'm going to get this as my first output. But I need to collect all of this and then look at which was the room with the smallest number, because that's one of the conditions that is given. So we will have to run a while loop here. So let's do that. Available rooms is equal to empty list, and then I say while I have something in my heap and min heap of head, okay, and the end time is still lesser than or equal to start, pull it out. Let's look at their room number. So I say meeting end, comma, room ID is equal to heap Q of heap pop of min heap. Now let's add this to the available rooms. So available rooms dot append RID. Now the reason why I'm appending it to available rooms and not just looking for the min room ID as it is because the other rooms that I'm not picking have to be available for other meetings. I have to push it back to the min heap. That's the thing. So now my min RID is equal to, so I can actually have, let's say, selected RID is equal to minimum of available rooms. Okay, now what we want to do is push this back. So heap Q dot heap push of min heap of end value. So what is the end that I have? The end is this one. Okay, so end, comma, what is the room ID that I selected? Which is selected room. Alright, so now let's remove it from the available rooms dot remove selected room ID. And then for the others, for available room in available rooms, what we will do is heap Q dot heap push of min heap of 0 end, comma, available room. Okay, so this is done. Now this was case 1. Now let us look at the else of this, which is nothing but case 2. That means we are getting delayed. So let's look at the delayed part. So here what I want to do is pick the one which is ending the earliest, and so I say heap Q dot heap pop of min heap, and I do it just once, and then we say this is going to be my selected RID is equal to this. I'm maintaining the selected RID because I need to update my counter, so this is important. And we say heap q.heap push, and what happens here is, let's add min-heap and then let's write. So now what happens here is my end time has gotten pushed. So what is the duration of my meeting? The duration of my meeting is n minus star, and it will run for this much duration after the meeting ends. So plus m end. Okay. Come on, what is the room number that we are taking? I'm taking RID. That's it. So once he push is also done, last thing to do is update the counter for this. So counter of selected RID plus equal to 1. Finally, I can return the room ID. So counter of index of the maximum value. So max of counter. Okay. So this is about it. Now, if you look at the time complexity, let's run through the analysis. So this is the meeting, right? So this is of size, let's say m, which is of order 10 power 5. So we are sorting it. So we get m log m here. Alright, and then on we are running through all of the meetings. So that is m times. And then for all of the meetings, worst case that we have to do is this while loop where I pull out every meeting. So I'm pulling out every meeting, and then for every heap pop, I will have to heap pop. Let's say we're popping all of the rooms. Okay. For every pop, I'm spending log n. So this is nlogn. And then again, I'm pushing them back. So this is another nlogn. Okay. And finally, the else case, which is just login. So if we put it all together, first we are taking the time complexity to sort it. Then for every meeting, we are taking worst case of n log n, which is 2n log n, which is the worst case. This, so we could be either using this, or in the other case we could be using just log n. So if we always had delayed meetings, then we would have gotten to something like m log n. Look at the space complexity. We are only taking order of n space, which is the heap. So the heap takes order of n plus the counter takes order of n. So the space complexity is also about order of n, which is the number of rooms. That's about it for this one. Hope this made sense. I'll see you again with the next one. Thank you. Bye bye.